All right. Okay, so we'll get started. Purpose of this is basically just to kind of give you a tutorial or kind of an introduction into what NVM Express is, if you don't know what it is, and just kind of a very, very light on some of the technical aspects. But there are a lot of performance advantages for NVM Express. So just to kind of get you started, I thought I'd start with just a quote from Henry Ford. Okay? So, if I'd asked people what they wanted, they would have said faster horses. Now we know, had they tried to do faster horses, horses were probably limited as far as how fast they could go. So sometimes it's time to usher in a new era, and that's what NVM Express is doing. So I can't figure out how to work. So the first question is, what's NVM Express? You know, having worked on NVM Express for almost 3 years, it's funny how NVM Express has kind of evolved, or the understanding of NVM Express. I've been to trade shows where people say, where can I buy an NVM Express? Are you guys selling products? The answer was no. What is NVM Express? So since that's a question that always comes up, I thought I'd start there. So what NVM Express is, NVM Express is the industry standard for enterprise and client non-volatile memory based storage solutions. Now, a couple years ago, when you saw this, you might have seen the words PCI Express in there. What you're going to find from Dave's presentation and follows me is that NVM Express has actually taken on a little more of a life than just PCI Express storage. What else is NVM Express? What does it do? It standardizes the register set, the feature set, and the command set to deliver performance. And I've got some performance numbers that I'm going to share with you guys. Now that products started shipping in 2014, you'll see what NVM Express is kind of capable of doing. One thing to keep in mind as far as NVM Express is, it was architected from the ground up for non-volatile memory solutions. So this allowed the command set to be more efficient than what we had with legacy command sets for things like HCI and SCSI. We're able to strip a lot of the extraneous commands out, so you get a very streamlined command set that's very efficient. And lastly, I want to point out that NVM Express was delivered by an open industry consortium for client, enterprise, and data center. Now, a lot of the initial thoughts on NVM Express was it would be adopted by enterprise and data center because you've got a lot of applications there. However, this year you're going to start seeing more and more solutions that are targeted towards client platforms, the laptops that you have in front of you, the desktops that some of us still have at home. My wife won't give ours up. I don't know why, but that's the way it goes. So, anyway. NVM Express, just to kind of give you an overview, how many of you are members of NVM Express today, or your companies are members? We got a few hands. Okay, if anybody else would like to join, we'd be happy to have you. We're actually a pretty robust organization in that last year we incorporated, which was a great maturation point for NVM Express. And currently, when we incorporated, we had approximately 105 companies, but a lot of those companies had actually been bought by other companies because, as you guys probably know, in the storage industry, there's been a lot of consolidation. So when we incorporated, one of my coworkers and myself, we had a bet how many members would we end up with by the end of the year. He had 40, I had 50. We're actually at about a little more than 80 companies now and continue to grow. It is led by a promoter group, which is basically those logos at the bottom. Some of those names you guys have probably heard of. Cisco, Dell, EMC, HGST, Intel, Micron, Microsoft, NetApp, Oracle, PMC, Samsung, SanDisk, Seagate. Any names that you guys haven't heard of on that list? All right, well, this is just a representation of some of our members, but this is the board of directors. Within NVM Express, we have a number of work groups. We have a technical work group. This group is basically responsible for defining specifications such as NVM Express 1.0, 1.1, and 1.2, which came out last year. The management interface work group, which is basically working on defining out-of-band management over PCI Express VDM and SM bus, which is a new initiative that we took on beginning last year, and expect that this specification is targeted for late this year, early next year to be released. We have a marketing work group. Actually, that was my job, and I'm leaving that job, was to help market and make the world aware of what NVM Express is. And by the show of hands of people that know what NVM Express is or have heard of it, I guess I did okay. NVM Express over Fabrics work group, this is also a new initiative, and Dave Minturn's going to go into a lot more details on this. One of the things that was a blessing and a curse on NVM Express was NVM Express was seen as being really, really efficient. And everybody saw it as PCI Express, and all of a sudden, out of the woodwork, all these groups came up and started saying, hey, could we take NVM Express and put it over your fabric of choice? Okay, name it. And there were like 5 different groups that were all going, hey, we're going to define a specification for that. And they approached us and said, hey, what do you think? And they all did it about the same time, which was really kind of funny how great minds, I guess, all work alike is what that really was proof. But they saw the efficiency of it, and Dave is going to talk about NVM Express over Fabrics, which extends NVM Express, and there's a specification under development for that one as well. So just to kind of begin with, and let you kind of know where NVM Express is, 2014 was actually an amazing year. We actually saw the first products announced and start shipping last year. Samsung actually announced their product in 2013. It began shipping in March of 2014. Intel announced their first NVM Express products in May, early June of last year, and those products are shipping. And then in September, HGST announced products as well. So on top of that, a lot of things were taking place within the organization. We basically released the 1.2 specification, which was done in October. And then at IDF, how many of you were at IDF last year? Show of hands. How many came by the NVM Express community? A couple fewer hands. Okay, those of you who attended last year and are going to be there this year, there'll be an NVM Express community again this year. But at NVM Express, we actually showed a technical demonstration of NVM Express over Fabrics, which Dave is going to talk to again. So it was really an exciting year, and of course, you know, it's great that you do all this stuff, but then it's really nice when people kind of recognize that what you're doing actually has some value. So I thought I'd just throw in this comment from Anand, where he actually tested NVM Express drives for the first time, and you know, who better than Anand to basically sum it up that the results were pretty impressive. So a lot of stuff is happening, and we're moving forward. From a driver ecosystem standpoint, very robust ecosystem in place. We have native inbox drivers, which include Windows 2012 R2, Windows 8, Linux open source drivers for Red Hat, SUSE, Ubuntu, Solaris, UEFI drivers, and FreeBSD drivers. Now, that's actually the first time I've ever seen the FreeBSD logo. I'm not sure what the heck that is, but it certainly caught my attention. And then also we have driver support for some of the legacy Windows applications and other OSs, Windows Server 2012, Windows 7, Windows Server 2008, and then VMware drivers are also available. So very robust ecosystem in terms of drivers. So why NVM Express? Well, in a nutshell, NVM Express is scalable, all right? It's flexible. It's also backed by an industry standard, so there's a lot of stability around that PCI Express interface. So we brought a lot of that stability, and we're bringing stability to storage and the storage interconnect to PCI Express. NVM Express also provides lower latency and increased efficiency. I've got some performance numbers coming up to show you how powerful or how substantial the performance improvements are, and so we'll show you that. And then increased bandwidth. Of course, PCI Express has additional bandwidth, so when we get to that next generation of non-volatile memory, there's actually headroom to support in the specification or PCI bandwidth to support that next generation and provide even greater performance, and you'll see some stuff on that. Low power as well, and security is provided from the Trusted Computing Group, Opal. If there's questions as I go along, feel free to put your hand up. Okay. It'll be good to see that espresso cake is working. Okay. NVM, just a technical support. So how NVM Express works is NVM Express basically works on a paired submission completion system. It supports deep queue depths of 64K commands per queue and up to 64K queues. It supports MSIX and interrupt steering, which enables even performance scaling, okay? It's got a streamlined and a simple command set. Now, this command set, basically 13 commands is all it takes to get an NVM Express device up and running. In comparison with something like HCI or SCSI, you're talking in the neighborhood of 400 commands for those. So you can see, by an order of magnitude, you're going to get much greater performance with NVM Express than what you would with SCSI or HCI. Okay, and then it's been built, as I mentioned, it's built for the future. When we set out, we didn't want to define a specification that would only last a couple of years. We knew that we needed to define something that would scale to the future. And with NVM Express, as I mentioned, it's going to support that next generation of non-volatile memory, which is going to provide performance that's closer to DRAM at a price that's closer to NAND. Okay? So, performance. All right. So, it was really great that products came out last year because we were talking about how good the performance numbers really were. But until you actually have product, you kind of hold your breath. And what we did was when we got products, we actually compared them versus SATA and versus SAS. And you can see that taking a look at 4K random workloads, say on 100% random reads, NVM Express is approximately 3x better than SAS 12 gigs. In the case of 100% random writes, it's about 1.5 times better than 12 gig SAS. Now, on a sequential standpoint, 100% reads, you're seeing over 2x better performance, and on writes, greater than 2.5 times better performance. So as you can see, from an IOPS standpoint, it's pretty impressive. Pretty impressive performance jump over that. But that doesn't tell the whole story, because when you're actually looking at things, you need to analyze what really, really matters. So what matters in today's data center, you're chuckling. Oh, there's a question. The greens? Greens is SATA. So, sorry, I kind of went by that, glossed over that real quick. The blue bars are NVM Express, are PCI Express with NVMe. The red bars are 12 gig SAS, and the green bars are SATA 6 gigabits per second. Okay?
What kind of drives are used on the 12 gig SAS and on the SAS?
Great question. And the screen's really small here, so I'm going to have to walk over here so I can actually read it. But basically, okay, it doesn't say what that drive is, but I can tell you what that drive is. That drive is an HDST SAS 12 gig. I can get you the model number if you want.
But it's a rotating memory drive.
No, it's a SAS drive using. It's a SAS drive.
What I'm asking is it magnetic rotating memory or is it non-volatile?
It's non-volatile memory. Okay. I can get you it's the UltraStar, and I can get you the actual model number. Okay. Yeah. This is a comparison of flash to flash. All these drives are using flash. Okay. All right. Any other questions before I go on? All right. Okay, so analyzing what matters. So what matters in today? Was there a comment on?
No, that helps. It wasn't clear from the chart.
Perfect.
It was all flash.
Perfect. Sorry, I'd say next time I give this presentation, I'll do a better job, but this is it. Just kidding. Actually, I'm going to have to talk about this stuff in my new job, so that's all right. And I don't have any problems with that. That'll be great. So what matters in today's data center isn't just IOPS and bandwidth, okay? It's actually more than that. So let's take a look at efficiency of the software stack, the latency, and the consistency. So what we did, and the performance numbers you're going to see coming up, basically we took a server, and again we compared a 6 gig SATA device and a 6 gig and a 12 gig SAS device versus an NVM Express PCIe Gen 3 solid state drive. Okay, so it's not strenuous on purpose, all right? Basically, it was just to evaluate the protocols and not the server. All right. So, efficiency of performance. Okay, before I get into this, can we all agree that CPU cycles in high-performance computing are precious? Anyone disagree with that statement? You started to raise your hand, but then you put it on your chin, so you're okay. All right. Each CPU cycle that's required for an I/O adds latency. Everybody agree with that one? NVM Express takes less than half the CPU cycles per I/O as SAS, is what you're going to see on this chart. So what we have here is, this is a comparison of the various media or the various devices and the CPU clocks per I/O. And as you can see in this very first chart, the NVM Express, that's the low bar. And lower is better. Okay? Relative efficiency on the right-hand side, as you can see here, higher is better. The more efficient the drive is, the better your performance. And on this one, NVM Express is the highest bar. So basically, that's a pretty significant performance jump with NVM Express PCIe. Okay? Now, along those lines, latency of NVM Express. All right, so the efficiency of NVM Express directly results in leadership latency. When you're one of the things that you're going to notice here is that, again, NVM Express on the left-hand side, average latency with NVM Express is lower than with SATA or SAS 12 gigabit per second. Relative latency, again, lower. So even when you take a jump from SATA or SAS 6 gigabit to SAS 12 gigabit, all that you're basically getting is approximately 60 microseconds of savings with that. In comparison, NVM Express is more than 200 microseconds average latency lower than 12 gig SAS. All right. Consistency of NVM Express. All right. Again, basically, SAS is a mature software stack, as you guys know, and it's got a decade of tuning taking place. Yet, in the first generation of NVM Express, taking a comparison and looking at latency consistency, again, what you'll see is that NVM Express actually has lower latency, and it has the best latency consistency. Okay? All right. Now, one thing to keep in mind is this is the first generation of NVM Express. Over time, additional tuning is taking place, so we expect these numbers to get even better as we go forward. So, where does this really become important? All right. Basically, it's around the next generation of non-volatile memory. Now, there are a number of technologies that are being talked about as far as what's going to displace flash, and I'm not going to voice any opinions as to which technology is the best one, but we know what you're going to see is you're going to see performance on the next generation of non-volatile memory closer to DRAM in performance. You're expecting about 1,000 times better performance than what you get on flash today. At the same time, that price is going to be closer to NAND. So what this chart is actually showing a comparison of where is the latency today? What's taking the time on it? And if you go and you take a look, and I'm going to walk over here and I'm going to start talking louder. What you'll see on this chart is this is a comparison of NAND MLC SATA 3, NAND MLC SATA 3 with on-feed 3, and then NAND MLC PCIe by 4 Gen 3 with on-feed. And then here's the next generation of PCI Express. Now what makes up the latency today is basically a lot of the stuff up until miscellaneous SSD. NVM shred NVM transfer, that takes up a significant amount, as you can see, up to here. And in the case of SATA, up to here. Software and the miscellaneous SSD, the link transfer, the platform plus the adapter, and the software is all relatively the same. Now, when we get to the next generation of non-volatile memory, basically we're going from roughly 90 microseconds down to less than 20 microseconds. And as you can see from these bars, everything that's associated with the solid-state drive is relatively peanuts. And software becomes kind of your bandwidth bottleneck. So as we go forward, applications such as big data analytics, significant benefits from the next generation of non-volatile memory, and high-performance computing. There's a lot of applications there that are taking a lot of data, importing data, crunching data. Oil and gas. Any of you guys in the oil and gas industry? Okay. No. Okay. You guys need to invite some people from oil and gas, Jim. Those guys have huge files, and they're taking files and they're basically shooting sonar into the ground to identify pools for oil. And they generate these 3D maps that are pretty incredible and pretty graphic intensive. And next generation non-volatile memory is going to have huge appeal for things like high performance computing and other applications as well. So with that, it kind of comes down to, like I said, well, you can go and take that horse, you can try to make it a little bit faster, but at the end of the day, you're still going to end up with a horse. Or maybe it's time to take a look and move towards the future, because what's coming is pretty sleek. And I can tell you which one I'd rather be behind right now. Okay, so choice is yours. I hope you guys agree that this is the direction to go. And if you want more information on NVM Express, visit our website at nvmexpress.org. Okay, and with that, I will turn it over to Dave Minter. Are there any questions? Well, actually, I'll turn it over to Jim. Any questions from anybody?
Do you have a price roadmap, price performance roadmap to see when this is actually practically deployable in an HPC environment?
So, are you buying SSDs today?
Not in large amounts for HPC.
Are you striping your hard drives today to get that performance? Okay. At Intel, within our SSD group, we found that if you were striping your drives, you're basically using just a small portion of your drives to get that performance. From a cost standpoint, a lot of times, or from a performance standpoint, you can actually replace 20 hard disk drives with one SATA SSD today and get equivalent performance. In the case of an NVM Express PCI drive, you basically can replace 5 of those SSDs with one PCI Express to get the performance. In terms of cost, SATA SSDs, yeah, they're a little more expensive as far as the acquisition cost on a cost per gigabyte basis. However, you can probably do more with a lower volume of SSDs than what you could do with your hard disk drives today. So you've got some cost savings there. Now, in terms of PCI Express SSDs versus SATA SSDs, yes, today you are paying a slight premium, or most of the products that are available are priced at a slight premium for that additional performance. Over time, and I would say probably within the next 2 to 3 years, you're basically going to see PCI Express and SATA at roughly equivalent cost parity. Okay? Any other questions? Yeah.
How mature is the server, the software, and the PCI adapter from hot plugging perspective?
So the question was, how mature is the software or the drivers and support? Yeah. Right. Right. Okay. Okay. So the NVM Express 1.0 specification was released in 2012, or was it 11, David? I should know this, but yeah, 2012. And then the second 1.1 specification was released in 2013. Since the specification was released, NVM Express has a great relationship with the University of New Hampshire Interoperability Labs. And UNH-IOL runs interoperability tests for us. And we have had 3 sets of interoperability test sessions. So from a maturity standpoint, the specification is very mature. As far as the drivers are mature as well and continuing to mature in the case of we're addressing any issues that come up. You asked about hot plug. Hot plug is actually supported. It's basically a BIOS event, so just like any technology, surprise hot plug or surprise removal isn't recommended, and it doesn't matter whether it's a SATA drive or a SAS drive or a PCI Express drive. But in the case of NVM Express or any of those drives, if it's handled correctly, it supports hot plug. Okay. Any last questions or any other questions? Okay.
Providing your next gen supply with, software related things,
So what can you do? And the question was, software becomes a bigger portion of the latency contributor as you go forward, and what can we do about it? Well, number one, we are working with the operating system vendors to make them aware of it, and they're taking a look at how they can optimize their software. One of the names on our board of directors is a company in Redmond, Washington, and they're very keen on NVM Express and have actually already started doing some things on their side to try to optimize. One of the great things as far as NVM Express and having the breadth of companies that are involved in there or in NVM Express is we have the ability to work with operating system vendors and work with them to try to optimize their software to overcome some of that as well. Okay.
you're actually sure you have the right data going forward, because
We're working closely with them. All right. Any other questions? Well, you've been a wonderful audience. Thank you very much. Nobody fell asleep, so we don't have to send the coffee in. With that, Jim, thank you.